we are on the addition formulae, which is page 145 of your notes. And this is a year 2 topic technically, so it does say year 2, chapter 7, and these formulae, they look really complicated, but they're given to you in the formula book, so you don't need to learn it. And we have got some examples here, there's examples over here, but that will be for our next lesson. Today I'm going to do the ones from the textbook actually, so I'm going to go to Active Learn, and I'm actually looking at page, so this is chapter 7 in the year 2 textbook. I'm actually looking at these examples here. Example 1, I'm probably going to leave just because it's a tad tricky. I can go through it, but you probably won't get it. And it doesn't really make that much of a difference. And I'm going to look at example 2 instead. Okay, so I'm going to start off with these trig identities. So this is where you are adding two angles. Okay, so if I've got sine of a plus b, you've got sine is equal to sine a cos b plus cos a sine b. If you've got cos of a plus b, it equals cos a cos b minus sine a sine b. And if you've got tan of a plus b, it equals tan a plus tan b over 1 minus tan a tan b. Okay, so that first question, it says use that first result to show that cos of a minus b is cos a cos b plus sine a sine b. Okay, so what I'm going to do is I'm going to use this identity here. So I'm just going to write that out again. So I'm just going to write out cos of a plus b is cos a cos b minus sine a sine b. And then what I'm going to do is I'm going to replace b. I'm going to replace it by minus b. Okay, so if I do that, I will get that cos of a minus b is cos a cos of minus b minus sine a sine of minus b. Okay, and that gives me that cos of a minus b is cos a, and that will give me cos b. So cos of minus b is equal to cos of b. So I'll just write that out here. Cos of b is equal to cos of minus b. And you can check that out. You can try it with any calculator. If you had cos of 90, it would equal cos of minus 90. It's to do with the symmetry of the cos graph. So if you think about your cos graph, it looks like this, doesn't it? It looks like that. And it's symmetrical here. So they call this an even function. So if you've got, you know, cos of 90, which would be there, and cos of minus 90 is symmetrical, you'd get the same value. Okay. And sine of minus b, I'll give you this one as well. Sine of minus b is equal to minus sine b. So the sine function is not actually an even function. It's not symmetrical about that axis there. So you wouldn't get that they're equal to each other. It's equal to minus sine b. So here I'm going to write cos a cos b minus sine a. Now sine of minus b is minus sine b. So if I put times by minus sine b, that becomes a plus. This becomes a plus sine a sine b. Okay, so that is the identity for cos of a minus b. So if I go back to the beginning over here, and I can put in cos of a plus b, and I've got cos of a minus b as well. It's exactly the same, cos a cos b, except, and I've got sine a sine b there. Instead of a minus, I've got a plus there. So here, when you've got cos of a minus b, it'll be cos a cos b plus sine a sine b. Okay. Let's do another one. So these formulae, you should be able to see that I gave you the second one there, cos of a minus b. I've shown you how to get that. But similarly, you can show that sine of a minus b is sine a cos b minus cos a sine b. And tan of a minus b, so see the reversal of the denominator there. You've got tan a and it would go with minus tan B, and at the bottom you've got 1 plus tan A tan B. Okay, so here the plus there goes with the plus on the top there with a minus at the bottom there. All right, okay, still not doing this example. I'm going to do one from the textbook again. So I'm looking at example 3 from page 168, and I'll do that with you guys. So I'm going to copy it out first. So it says cos of A over sine B. So I'm suggesting you should copy this out with me. Minus sine A cos B. And I've got to prove it's equal to cos of A plus B over sine B cos B. Okay, so what I'm going to do, I've copied it out. There it is. And I'm going to pick a side. So with proof, you always got to pick a side and work with it and manipulate it, try and make it look like the other side. Okay, so what I'm going to do, I'm going to pick the left-hand side. So I'm just going to write left-hand side. And I'm going to copy that out. So I've got cos A sine B minus sine A cos B. And I've got two fractions. And I'm subtracting them, but I can only subtract if the denominators are the same. So I'm going to make the denominators the same by timesing this fraction by that denominator and timesing the second fraction by the first denominator. So if I do that, so I'm going to, what you guys call cross multiply, cos A cos B on the top minus sine A sine B over there. And on the bottom, my common denominator is sine B cos B. Okay, now my top line looks really familiar, cos A cos B minus sine A sine B. All right, so I'm going to go back to my formula here. Cos A cos B minus sine A sine B. Cos A cos B minus sine A sine B is cos of A plus B. Okay, so I'm going to put that in. So the top line is cos of A plus B all over sine B cos B. And that's what I've got on the right hand side there. So I'm just going to write equals the right hand side QED. I've proven it. Okay, so that's example 3 from page 168. I'm going to do one more, which is example 4. I'm just going to zoom in a tad. If you'll let me, yes. Okay, so can you copy out example 4? So it says 2 sine of x plus y equals 3 cos of x minus y, and it says express tan x in terms of tan y. Okay, so just copy this example down first and then we'll work through it. Okay, so I've copied it out, and what I'm going to do is this is an addition of two angles, sine of two angles added together, and here I've got cos of two angles where one is being subtracted from the other. So I'm going to use my addition formula here. All right, so if I use my addition formula on this side, I've got 2, and then I've got sine of x plus y. So rather than writing sine of x plus y, I'm going to use this formula here. Sine of x plus y will be sine x cos y plus cos x sine y. So I'm just going to put that in. So that will be sine x cos y plus cos x cos y. On the other side, I have got 3 timesing the cos of x minus y. So cos of a minus b. So again, you can go over here. Cos of x a minus b is cos a cos b plus sine a sine b. Instead of a and b, I've got x and y, but it's the same principle. So I'm going to write cos x cos y plus sine x sine y, like that. Okay. And then I will probably multiply out my 2 there, my 3 there. Let me just do that. 2 sine x cos y plus 2 cos x cos y. It equals 3 cos x cos y plus 3 sine x sine y. Okay, and then I want to get tan x, don't I? I want to get tan x and I want to get tan y somewhere. So what I think I'm going to do is I'm going to divide through. The only way I'm going to get a tan x is if I'm dividing through by cos x. Okay, so if I divide every single term by cos x, here I am, cos x, cos x, cos x, cos x, okay? And I'm also going to divide through, because I don't want any cos y's, I want tans, don't I? So what I'm going to do is I'm going to divide through by cos y, because that will make this into a tan y, okay? So I'm going to divide every single term by cos y as well. So here I am dividing everything by cos y, like that. And then I'm going to cancel down what I can. So that disappears, so does that, becomes a 1. Cos x divided by cos x, cos y divided by cos y, sine y. Oops, wait a minute. That doesn't cancel there, does it? Okay, so here I'm just going to see what I've got left. I've got 2, and I've got sine x over cos x, so that's tan x, 2 tan x. Everything cancelled there apart from the 2. Here, everything cancelled apart from the 3. And then here I have got 3. That there is tan x, so let's write tan x. And that there is tan y. Like that. I need to get tan x on its own, because it said express tan x in terms of tan y. So I'm going to try and get my tan x's together. All right, so what I will probably do is, let me put that on that side, okay? So I've got 2 tan x minus 3 tan x tan y. And I'll subtract 2 from both sides. So I've got 3 take away 2, which is 1. I've got a common factor there of tan x, so I'm going to take that out. And if I do that, I'll have 2 minus 3 tan y is equal to 1. And then tan x is equal to 1 over 2 minus... Have I made a mistake somewhere? Let me just check. Just checking I haven't made a mistake. Yes, I have. I made a mistake here, didn't I? This should be cos x sine y. I was thinking I'd made a mistake. I just couldn't spot it. And this is a sine y. Sorry about that, guys. Just go back and sort that out. So sine y over cos y actually makes a tan y there. So here I've actually got 3 here minus 2 tan y. So this is 3 minus 2 tan y. And I've got 3 minus 2 tan y here. And then I've got 2 minus 3 tan y on the bottom. That's my denominator, and that's it, I've done it. Okay. So got to be careful with all my cos x's and sine x's, but that's essentially it, done. Okay, there you go. I'll just put it all over there so you can see it. I'm doing one more example, which is question 9 from exercise 7a. I'm doing 9a because I think you might get stuck without me doing this. So the question was, I'll just zoom in. It said, question 9, express the following as a single sine, cosine or tangent. So the first one says, sine 15 cos 20 plus cos 15 sine 20. Okay, so what you have to do is spot that this looks very similar to this identity here, sine of a plus b. Sine a cos b plus cos a sine b. So here, a here is 15 and b here is 20. So this here is sine of a plus b, which is sine 35 degrees. And that's it, that's done.